So Cummins started an analysis-led design initiative really to get our products right the first time and to do it faster and to have higher quality for our customers. Cross-functionally, I'd say that's been one of the bigger challenges, and it's something really just recently we've started to look into. How do we do that better? We're reformulating our technical functional excellence groups. We're reassigning some groups, we're getting rid of some groups, and we're going to figure out and go down the path of how do we make those teams more cross-functional, to understand the requirements that are there before them, and how we get to collectively, again, how do we deliver the best products to our customers. So with regard to how we do our optimization and how in the past we've been more focused on components, and now we're trying to make the switch to more subsystems and systems. It's not that we don't want to optimize our components, especially in areas where we can save a lot of money. We will do that. But the best components, each one optimized on its own for whatever the requirements are before it, may give you a subsystem or a system. And so really that's the key. How do we put these components together, and how do we understand them and make trade-offs between them? So in the past, our first and foremost focus, and will continue to be our first and foremost emphasis for our components, is just to make sure they work. If they can be optimized for weight, for cost, or whatever it is, we'll pursue that. But at the end of the day, we have a tremendous opportunity to combine our various components into the engine and into the power generation, and to put the best possible engine or power generation unit together for our customer. And so that means optimization as a whole. And so that may mean suboptimal filtration or after treatment or turbocharger if it's to the benefit of the overall system. And again, for the things that matter to our customer, things like total cost of ownership, initial cost, quality, fuel economy, and emissions, and the things, again, that the customer is concerned about. So when we look at a specific component or subsystem, we like to drive all our models from the same place, at least from the same CAD model, and that's how we typically work today. What we don't have is a single meshed model or a single FEA model. It depends on the physics, and so things change. And so when we're doing combined, let's say CFD, structural, thermal, and modal, they will all drive back to the same CAD model. But we may want to do some things like morphing the mesh, changing the geometry that way. But we do want to be able to go backwards and say, whatever we did, how do we drive it back into the CAD? So wherever we can, common CAD, look at all our physics, and using things like Mode Frontier to optimize against all those parameters, all those constraints, but then drive it back to the same CAD. When we talk about interoperability and computing resources right now is not an issue that we have. We're installing high-performance computing grids in a couple different places around the world. We have an unlimited agreement with ANSYS with their core software, and so right now the challenge is for the users around the globe to use as many licenses and do as much simulation as we can. And our grid actually has been doubling in capability and capacity about every 6 months, and we designed it that way. So we can run lots of models, we can run very complicated models, and we're doing that. Interoperability, I would say, is the challenge. It's going to continue to be the challenge. There's a trend in the software industry to vertically integrate. I think that's okay, but I think longer term, even those companies are going to have to work together, and interoperability will become more and more important. And right now it's taking a lot of time for the end users at companies like Cummins to make sure these codes can talk to each other. A lot of individual people are having to write scripts and to do things to make sure things talk with one another. The more we can standardize and determine how to do the interoperability problem, I think is going to be a big help.